Okay, accelerated 2. This is your March 3rd to March 6th. 3, 4, 5, 6. Do we not have school and stuff? Anyway, in any case, this is your video for that week. We're talking about circles. We're talking about right triangle side lengths, and you have the probability statistics and probability unit test. All right, so that will be a good one to complete. And post traffic light problems about. I'm not going to go over those problems right now because we did probability earlier in the year, and you could go back to that if you need to. But if you want to do that during class, we can totally do that. Just post your traffic light problems so we can focus on the ones most needed. But let's talk about the new learning. You probably know about circles, but we got to cover it, make sure that we're on the same page. And there's a lot of different circle vocabulary. So before we even answer this question, let's use it as an opportunity to talk about circles. We have, this is a circle, and this is the center of the circle. It looks like somebody's eye going at the center. And actually around the circle is called the circumference. All right, circumference of the circle. We have a radius is from the center to the edge of the circle or to the circumference of the circle. And then we have what I like to call, and others as well, from one edge to another edge through the center, that's called the diameter. All right, diameter. Then we have another segment in the circle that goes from one part of the circle to the other, straight line, and it doesn't pass through the center. That's called a chord. And so that's a chord. And so that's pretty much everything, except we can keep going. So this, if you shade in this little pizza slice, we give that a special name. That's called a sector. And actually, I think we are going to talk about areas of circles and areas of parts of circles, which would be areas of sectors. We could also find the area of this little shaded guy. We won't do that right now, but we could. That would involve the Pythagorean theorem, which you just learned. It's great. Okay, so let's do one more thing about circles. Let's draw points on the circle. We know about points. So A, B, and let's do one more point on the circle, C. So points on the circle A and B and C, what would you want to do with those? You would want to go from one point to another point. The most natural thing to do with a point, right? If you're at one point, you want to go to the other point. So going from A to B, you can go in two different ways. You can go the short way, which we call the minor arc. A, B, and then put a little arc over it. Remember, we've talked about segments and put a straight bar over it. But then we have a major arc. Major arc. So the major arc would be the long way around. And that would be to go from A to B, but go through C. And so you want to use 3 letters in that one. A, C, B, so 3 letters. Way more than what we're going to talk about. But I just wanted to tell you because you guys do a really good job of listening. So now when you go to geometry, you can say, oh yeah, Mr. Field told us that. All right, so the radius of a circle is 5. So I'm going to say R equals 5. The diameter is twice the radius. The diameter, we can say D equals 2R. So 2 times 5, it's 10. That was pretty easy, right? All right. Is there anything? Radius and diameter. So yeah, multiply, divide by 2. I'm not going to do any more. You can figure that one out. But let's talk about this one. A circle has a circumference of 7,850 units. What is the radius of the circle? So I told you the circumference is all the way around the circle. And they're asking you for the radius. The only way to find that would be to have a formula. So there is a formula, and it is C equals pi times D. Or you could use C equals 2 pi times R. I like 2 pi R. I think I just like saying 2 pi R. But then pi D, that's a great one too. So choose whichever one you want to use. Let's use pi D, okay? Even though I like the other one better, don't know. So our circumference is that. And so I'm going to substitute that in for C. 7, 8, 5, equals pi. And D, I do not know. And do you guys know about pi? Pi is 3.14159. It goes on forever. It's an irrational number. And pi is the ratio of the circumference to the diameter. All the way around the circle is 3 times, a little bit longer than 3 times as long as just going straight across. That's what pi means. Here, though, we're going to use pi to solve for the diameter. And so we need to divide by it. It's just a number. It looks like a variable, but it's just a number. So, and it says use 3.14 for pi. So let's divide that by 3.14. And yes, some of you will be happier than others. You can use a calculator for this assignment. It's okay. Let's see if I can keep going to the wrong menu here. Okay. How do you use this? Oh, got it. I got it. All right. 7850 divided by 3.14. You get 2,500. Amazing. How did that happen? And so that means that R is going to be, half of that, which is 1250. So radius, half the diameter, 1250. All right. So go ahead and try that. You got the circumference formula now. You can use either one. And now let's relate area to scale drawing. See, I was not supposed to do that one. It's supposed to be circumference parts of a circle. Let's see if it goes to the right one this time. Okay. Maybe I clicked on the wrong thing. All right. So, and then next week, are we doing area? Yeah, next week is area. This week is circumference. Parts of a circle. So like I was talking about arc length, right? There's a semicircle is half the circle. So if C equals pi D, but then if this is half the circle, or you know what, this time, let's use C equals 2 pi R, because they gave us a radius, so. Well, we're just gonna end up right back at C equals pi D. Okay, so anyway, 11, then I multiply those two and I get 22 pi is the circumference. But if they want half the circle, then just divide it by 2. And C over 2 would be 11 pi. Amazing, 11 pi. And again, we're going to use 3.14 for pi. So 11 times 3.14, 34.54. There you go. And so they could give us a half the circle. They could give us a fourth of the circle. So find the circumference and then divide by 4. And that will be the length of just that arc. So a fourth of the circle. So have fun with that one. Shouldn't be too bad. And then the last one here is right triangle side lengths. So we talked about this at the end of class today. We're trying to justify some triangles as right triangles. So there's this little not a converse to the Pythagorean theorem, but now forgetting what it's called, but sometimes you get this theorem and then you get little offshoots of the theorem that's like, oh yeah, if that's true. And there's a word for it and I can't think of it, but maybe you could look it up. So the Pythagorean theorem says that a squared plus b squared equals c squared in a right triangle. Okay. Lemma. It's not lemma. It might be lemma. Okay. So that means that we have three types of triangles now, mind you. Okay. So a squared plus b squared equals c squared in a right triangle. What kind of triangle would it be when the two shorter sides and you add them together and that's longer than, what kind of triangle would that be? Think about that. So now we got a shorter c, right? So that would only happen if that would happen in an acute triangle. Okay, so if c is shorter, you can see that we have acute angles. So this is acute. Remember acute triangles, and what's the last one? Obtuse triangles. All right, so that would be when a squared plus b squared, it is a triangle, but a squared plus b squared, you add them together and it's less than c squared. So c is a very long side. You get a very long side, you're going to have an obtuse angle. That's the only way to have a triangle with a very long side. And that means a squared and b squared, even if you add them together and square them, is going to be less than c squared. But in this particular assignment, all you have to do is find out if a squared plus b squared equals c squared, and then you know you got a right triangle. So let's just do one of them. 9 squared plus 12. You know what? This, I could divide everything by 3, and I would be back to a 3, 4, 5. So I know that one, not even going to do the theorem. How about 2, 6, 38? So 2 squared plus 6 squared is 4 plus 36 is 38. No, that's 40. So 2 squared plus 6 squared is 40, not 38. So that one's out. And then how about this one? 9 plus 81. I'm just squaring 3, squaring 9. That's 9 and 81, and that would be 90. 81 plus 9 is 90. So that one's out. So even though it says to choose all that apply, the only one that really applies is A. Okay, so go for it. This really, maybe another easy week, except for now you got this unit test, which is 10 questions, 10 to 20 minutes. Okay, so have fun. The Chromebooks are charged.